Yan. So, okay. There we go. So, hello. Welcome sa ating lesson ulit. For the record lang, ngayon we're going to start with our last lesson sa physics, which is dynamics, no? Dynamics. Dynamics deals with forces, di ba? Kung dati puro, lang tayo, speed, ganyan, kinematic quantities. Ngayon, we're going to focus with forces. And you'll see na how related kinematics and dynamics are. Kumbaga, the usual speed, velocity, acceleration, those vectors, how related are they to forces, no? So, I'm sure alam niyo na yung force equals mass times acceleration. Pero, ang force is actually defined as a pull or push, no? Push or pull. Tulad dito, no? So, you might know that, pero actually, ang force is defined as the interaction between an object and its environment, okay? Object and its environment. So, kaya you'll see next time, in your higher physics, you'll see na lang bigla, merong force na, ayun, yung gravity, di ba? Yung apple. Okay? Ano pa ba? Sa electricity, may electric force na tinatawag, no? So, kasi kapag pinasok mo yung isang electron sa isang field ng puro electrons, magkaka-force doon, no? Yung mga ganon. Basta as long as an object and its environment interact, merong force. Kapag nag-swimming ka sa tubig, may force yun. Okay? So, a force is a vector with magnitude and direction. Unit is Newton. So, common kinds of forces. Meron tayong mga common kinds of forces. We have contact force. Direct contact between two objects. So, example, nag-push ka. Ayan. Diba? Merong contact, diba? So, contact force yung pag-push mo. Yung pag-pull mo rin through the tension, meron kang contact force. Okay. Ano yung mga kinds of contact force? So, unang-una, normal force. Contact force exerted by a surface on an object in which it is in contact with. It acts perpendicular to the surface of contact. Always perpendicular, always. So, yan, tingnan nyo, height na slant, perpendicular pa rin. Next, friction force is a contact force exerted by a surface on an object in which it is in contact with. It acts parallel to the surface of contact, parallel naman to, opposite to where the object is moving. Kaya, 'di ba, ano bang magandang way to illustrate friction? O kaya umiinit yung mga example. You'll see later, no? Tension force naman, pulling force exerted by a stretch rope or cord on an object to which it's attached, no? Sige, balik tayo sa friction, no? So, example, naglalakad ka, hindi ka nadudulas. Bakit? Kasi may friction. Acting to where you are moving. Acting opposite to where you're moving. Para hindi ka madulas, no? And kaya umiinit yung shoes natin kapag nagsaslide tayo, no? Tension nga sa rope, no? And take note yung direction, palabas siya parati, no? Palabas siya sa object, no? It goes towards where you pull. Okay? Always remember that, no? A long-range force naman acts when the objects are separated by empty space. Example, gravitational weight or force is the force due to gravity that pulls an object towards the center of the earth, no? Okay, as early as now, sasabihin ko na sa inyo that normal force is not equal to weight, okay? Sasabihin ko na sa inyo yun. Mamaya, we'll discover more, okay? Last one, ito, free body diagram. It is a diagram that shows all forces acting on an object. Example, force of block on runner. Ayan, pag ganun siya. Kasi ito yung block, di ba? So, pag ganon, force of the block on the runner, and weight, no? Ano pa? Example, ito. So, paano ba i-drawing yan? You just draw a point, tapos put all the forces acting upon it. That's a free body diagram. Mukha siyang vector diagram. No? Mukha siyang vector diagram. Kasi, in fact, it is a vector diagram. Okay? Buoyant force, ayan, you see? Pataas siya kasi counters the swimmer's weight. You don't know that. Next time na yan. Weight. Thrust, di ba? Sa airplane, pag thrust, force that moves you forward, di ba? Yun yun. Yung drag naman that opposes you. Ayan. Kasi kapag nagsiswimming ka, nararamdaman mo yan. May nagre-resist sa'yo. And there are some driving forces on you to continue moving. Ayan. That's the free body diagram. Ito, here's another way of writing free body diagrams, no? You'll see more kung paano lahat yan mamaya. So, superposition of forces, the same lang as before. Sa vectors, vector sila, di ba? So, the resultant force or the net force, net force, is equal to the vector sum of these two forces, no? Ayan. Two forces, F1 and F2, have the same effect as a single force are equal to their vector sum. So, paano kumuha ng net force? The same as we do sa vectors. Add all the forces, add all the x, add all the y. Taking note yung directions, resultant, square root, tapos yung theta or direction, ry over rx, no? Yan, this is just the illustration. And ito. I want you to try this. Sige nga. Try nyo nga to. Let's see if naalala nyo pa yung vectors natin. Sige nga, let's try. I'll give you 5 to 10 minutes. 2 minutes. If not, I'll give an extension. I wanna make sure na you know how to do your vectors kasi sobrang important ka today. Okay? Sige, let's discuss. Oh, yan, di ba? 53 degrees. So, Rx, di ba, 50, 120 to 50. X component, 50 plus 250, plus negative, no? Plus negative 250 cosine 53. Y? 120 plus 250 sine 53. You'll get, let me fix my resolution. Teka lang, ha? Negative 100. Ito naman sa baba, 319 or 320, no? So, getting the resultant, let's see, ha? Tama ako. Wait lang, may mali ako. Negative to. Kasi pababa siya. Isa pa, ha? $80. 80 lang pala to. Yan. Equals 128 newtons. Direction, ano mapansin nyo? Positive y, negative x. So, second quadrant, no? Second quadrant. So, whatever we're getting here, i-add natin sa 180. Negative 38 degrees, no? Negative 39 degrees. Or, if we get the answer, 141 degrees, no? 128 newtons, 141 degrees. Please tell me if hindi nyo gets. Okay? Sige, let's continue. Ayan. Next. Ngayon, let's move on with the three laws of motion. I don't think I discussed yun pa to, so let's discuss. So, first law is called the law of inertia. An object acted on by no net external force has a constant velocity, which may be zero. Kasi and zero acceleration. Or in short, an object will continue to stay at rest or continue moving at a constant velocity unless a net external force acts upon it. Constant velocity meaning no acceleration, no? And actually, pag no acceleration, zero, di ba? And kapag hindi disturbed or at rest, or it moves at constant velocity nang hindi dinidisturb, ang sum of forces acting upon it, or net force, is zero, no? Zero, in equilibrium. Kapag in equilibrium, hindi ibig sabihin, hindi siya gumagalaw. Hindi ibig sabihin, walang nag-act sa kanyang force. Balanced out yung forces, so nag-cancel, or walang force na nag-act at all, yun, no? Ibig sabihin ng equilibrium, equal to zero. So, yan, example, yung stone na to, So, sabi natin, an object acted upon by a balanced force is at rest. So, ito, itong dalawang tao na to, magsinlaki sila, then they push as in exactly the same way, same angle, same strength exerted, di gagalaw yung object kasi cancelled out yung forces. In equilibrium siya kahit may forces na nag-act upon sa kanya. Ito naman, they push in the same direction. So may net force, may unbalanced force, hindi balance eh. And that force changes the object's speed and direction. Okay, next. Ito naman, an object, itong football, di ba? Example. Kapag nilagay mo lang siya dyan, sa field, di siya gagalaw, di ba? Kaya lang naman siya gumagalaw kasi sinisipa lang natin siya, which is the unbalanced force, no? And that ball stays in motion until it hits the net or something else, di ba? And yung net na yun ang nagpro-provide ng unbalanced force, no? It would change speed and direction pabalik sa player. Okay? And actually, that's how seatbelts work. Kaya importante yung seatbelts, guys. Example ito, no? Example ito. Dahil gumagalaw yung object, so gumagalaw ka rin, di ba? Pareho kayo na speed. Kaya lang, bigla siyang nakasagasa ng wall. Ano na yung sumagasa? Yung motorsiklo or yung kotse mo, example. Ikaw, gumagalaw ka pa rin nun. Kasi wala naman, kung hindi ka nag-seatbelt, walang naman nag-resist sa'yo, di ba? Kaya importante yung seatbelt, no? To keep you in motion. To anticipate sudden changes in force, sudden unbalance, kundi patay ka, salpok ka, lilipad ka. Kasi nga patuloy ka pa rin gumagalaw eh. Wala nag-obstruct sa'yo pag walang seatbelt. Kaya importante yung mga seatbelt. And the tendency of an object to maintain its state of rest or uniform velocity with a straight line is called inertia, no? Inertia yung tawag doon. Kaya this is how this works actually. Newtonian cradle, if you know what this is. So mass is the measure of inertia in an object. The higher the mass, the harder it is to change its state. Okay? Example, hindi siya weight ha, magkaiba siya sa weight. Remember that, magkaiba siya sa weight. Wait lang, ah. Sorry, okay. Let's continue. So, the higher the measure of inertia or yung mass, the harder it is to change its state. Hindi siya weight, ha? Take note, hindi siya weight. Magkaiba yun. Oh, example, sa bola, di ba, mas nababato mo siya, mas napapagalaw mo yung bola kaysa dito sa kotse. Di ba? Oh, kasi mas mabigat to. Di ba? Ano pa ba example? Oh, kaya pag sinipa mo yung mas mabigat na bola kaysa sa mas hindi mabigat na bola, mas masakit nararamdaman mo, di ba? Kasi nag-exert ka ng more force to change its state, okay? So the higher the mass, the harder it is to change its state, di ba? Mas mahirap mo siyang pa-accelerated, okay? And kaya yung mga tao, sinasabi nila, common saying to, mas mahirap pigilan ng truck kaysa yung bola, di ba? Yun. Kasi mas malaki siya. Common sense naman yun. Next, law of acceleration. If a net external force acts on an object, then the object accelerates. No, the object accelerates. Ano yung sabihin nun? The direction of the acceleration is the same as the direction of the next external force. So, yung sabihin nun, mass times acceleration equals force, net force, di ba? So, in short, net force causes acceleration. Oh, example, ito, yung ice pack, nagsaslide sa ice, no? Nagsaslide siya sa ice. Then, kapag patuloy siya nagsaslide, na acceleration niya kasi para-pera naman yung velocity. Ngayon, nilagay mo yung kamay mo. Pinulak mo using your hand, di ba? Kitang-kita naman na nagbabago yung acceleration, nagbabago yung velocity. Lumalaki, di ba? Lumalaki kasi yung arrow. Pero take note na, as you can see, force is the same direction as acceleration, no? And ganoon din naman sa kabila. Example, tinatry mong slow down yung ice pack. If you cause an external force opposite to the velocity, ayan, saka pa lang siya mag-stop. And it would cause deceleration. See? You exert the force towards the left and the acceleration will always be there. Kasi di ba sabi ko sa inyo, pag opposite ang acceleration sa velocity, it would slow down and stop eventually. Di ba? So yan, directly proportional to the net force, ang acceleration, and inversely proportional to the object's mass. F equals ma, or A equals sum of F over M. So, ganun pa rin, no? You can use the component method. At each component, sa x component, x equals max, y equals may, z equals maz. We'll look at that later. So, ayan, it explains din kung bakit mas mahirap magtulak na mas mabigat na mga bagay kasi the higher the mass, the higher the force needed to push it at the same para magkaroon ng acceleration na yun. Diba? Kasi force equals mass times acceleration. Kaya siya mas mahirap, no? Ayan, ito, example. Try this out. Game. 5 minutes. Okay, 1/2 g. G is the acceleration due to gravity. So, 9.8 meters per second squared siya. Okay, time's up. Hmm. Diba? Let's see yung given, ha? Oh, net force needed to accelerate at 1/2 g. Oh, A. F equals ma, diba? So, that's equal to 1,000 times 9.8. 98,000 newtons. Letter B. F equals ma pa rin. Equals to 200 grams, so 0.2 times 9.8. 0.002. So, mga... Ay, sorry. Sorry. Sapay. Oh, 1,000 times 1/2 times 9.8. 4,900, no? Letter B. F equals ma equals 200 grams, 0.2 kg times 1/2 times 9.8. That's equal to 0.98 newtons, no? Ayan. Next, paano naman to? Sige guys, I'm gonna give you another chance. I'll give you 5 minutes ulit. So, anong kailangan dyan? Nako, mayroong hindi maka-join. Tara. 5 minutes ulit. Sige, go. Dali, kinematics. O, di ba you're going to get the acceleration muna. Tapos, tsaka nyo, kukunin yung net force. Sige, game. I'll give you another 3 minutes, no? Pag may sagot na kayo, please, PM nyo lang ako, okay? Sige, I'll give another 3 minutes. Sige, I'm going to give another... Oh, sige. Hindi eh. Hindi eh. No. Sige na, discuss na. Game, ha? Diba? Let's look at the given. Sandali. Average net force is needed to bring a car to rest from a speed of 100 kilometers per hour within a distance of 55. VI equals to 100 kilometers per hour. Convert ko to meters per second na. 100 times 1,000 over 3,600 seconds, no? So, mga 27.8 meters per second. VF equals 0. Distance equals 55. Mass equals 1,500 kilograms. So, we just use kinematic equations, no? Kinematic equations muna. Kasi kailangan natin yung acceleration, eh. Acceleration equals VF squared. Diba, VF squared equals VI squared minus 2AD. Ay, plus 2AD. A equals VF squared minus VI squared over 2D. VF squared equals 0. So, 0 minus answer squared over 2 times 55. We'll get negative 7.01 meters per second squared. F equals MA. Take note ha, pwede rin negative yung force, no? 1,500 times negative 7. Negative 10,522 newtons. Or around negative 1.1 times 10 to the 4th newtons, no? Yan, that's the answer. Next. Sabihin niyo sa akin pag di nyo gets, ha? Please. Huwag mo yung magtanong. So, last law is law of action-reaction. Law of action-reaction. Ibig sabihin ng law of action-reaction. It happens whenever one object exerts a force on a second object. The second object exerts an equal force in the opposite direction on the first. Ayan. FAB equals negative FBA. So, take note na yung force can be classified as an action and the other can be classified as a reaction. These two forces have the same magnitude but are opposite directions. Take note that they act on different objects. So, meron dalawang pairs of force na hindi lahat ng pairs of forces ay action-reaction pair. So, yan. In layman's terms, to every action, there's an equal and opposite reaction. Naalala niyo yung ginawa niyo dati sa IAS? Yung apple and the earth? I'm sure ginawa niyo yun. Dapat, nung grade 7 kayo, I'm sure dapat ginawa niyo yun. Kasi, yun, napakita sa inyo, di ba, na the apple exerts force on the earth and the earth exerts force on the apple, di ba? So, example, ito, oh. Example, kicking a ball. May force yung bola sa'yo, may force ka sa bola. Kaya ka nasasaktan minsan kapag nag-ano ka ng bola. Kapag sumisipa ka ng bola. Diba? Yun. Next, itong force, ito, pulling a sled, no? O, see, we have 3 action-reaction pairs. Friction by the ground, tsaka force on the ground exerted. Friction on the sled by the ground, which is the force by the ground, tas force on the ground by the sled, diba? Kaya hindi nadudulas yung sled. take note yung subscripts, SG, GS, parati silang magkabaliktad, no? Pag ganyan, action-reaction pair. Kaya hindi nadudulas yung assistant kasi may friction on the ground, no? Para hindi siya mahulog. Ayan. Ganun din, no? Kaya kapag ginanon mo yung kamay mo sa table, masakit. Kasi, pwede ka masaktan, no? Kasi may force na in-exert pabalik yung table. Next. Force on skater, force on wall. Yeah? Tapos lastly, kaya siya hindi nadudulas. Kasi, friction, friction papunta dito, yung force ng tao papunta dito. Okay? So, let's examine yung mga action-reaction pairs, no? Yan, example, force of table on the apple, force of, example, itong two forces acting on the apple, di ba? F of table on apple, F of earth on apple. Okay, hindi siya action-reaction pair kasi they don't follow Newton's third law kasi they act on the same object, guys. They act on the same object, di ba? Ayan, no? Table on apple, earth on apple. Ito na itong dalawa na to, let's see. F of earth on apple, F of apple on earth. Yun yung sinasabi ko sa inyo dati sa IS. They exert gravitational force on each other. Next, the action-reaction pair for the interaction between the apple and the table. Ulit, ito naman, F of table on the apple, F of apple on the table. Di ba magkaiba? Table on apple, apple on table. So, action-reaction pair sila. And lastly, kapag tinanggal mo yung table, etong dalawa, hindi sila action-reaction pair, no? Pero itong dalawa, oo. No? Action-reaction pair yan. Next, the block, the rope, the mason. Same setup lang. So, R on M, rope on mason, mason on rope. Ito, hindi to reaction-action pair kasi wait. Okay. Itong dalawa, hindi siya action-reaction pair kasi they act on the same object. On R, di ba? On R, on the rope. Yung mason sa rope, yung block sa rope. Dito rin, action-reaction pair din to. Di ba? Kasi B on R, R on B. Okay? Next, let's go to mass and weight. Mass is the measure of inertia in an object. The higher the mass, the harder it is to change its state. And na-discover rin natin kanina, the higher the mass, the higher force is needed to cause acceleration. So, weight is the force due to gravity. Present all the time yan, guys, kahit saan. And it is not always equal to the normal force. Okay? You'll see later mamaya. Weight equals mg. I'm sure you're familiar with this formula. Ayan, see, kahit may naghahang na object, meron pa ring weight. No? And it's unchanged yung value. Parati siyang ganun. mg siya parati. Okay, tapos isa pang note. Kaya pag napunta ka sa moon, hindi nagbabago yung mass mo kasi nga hindi naman nagbabago yung mass. Yung weight na nagbabago kasi nagbabago yung acceleration due to gravity. And sabi nila, the higher you are or the farther you are from the center of the earth, the weaker the acceleration due to gravity is. Okay? Always remember that. I'm going to give you 5 to 10 minutes ulit for this one. Ito yung weight, guys. Weight na to. Ito na yung weight, no? Yun yung weight. Kailangan mo yung acceleration. So, I'm going to leave it up to you. Okay? Game. Sige, 3 minutes left. One minute. Okay, time's up. Ay, sige, may nagta-type. Let's see. Positive, negative, Sandra. Negative dapat. Siguro you didn't take into account your sign, okay? Okay na maging negative ang acceleration. Always remember that. Okay? Game, let's discuss. Oh. A 2.45 times 10 to the 4th Newton track traveling in the x direction makes an emergency stop. The x component of the net external force acting on it is negative 1.83 times 10 to the 4th. No? What is its acceleration? Oh. Diba, mass times acceleration. So, let's get the mass first. Diba, weight, mg. Weight over gravity. Next, F equals ma. A equals F over m. F over W all over G. Negative 1.38 times 10 to the 4th over weight over G, 2.45 times 10 to the 4th over 9.8. Get, teka, 1.83 na, 1.83 pala. Negative 7.32 meters per second squared. Okay? Next. Dito na si Armia. Okay, sige. Sige, just a bit short of recap for you. Yung natutunan na natin, F equals ma. And yung sum ng forces anywhere is always ma, no? Sa lahat ng component. Next, weight equals mg, no? I think alam niyo naman na to. Weight equals mg. Yun na naman yung important concept na you missed. Okay? Next. Wait. Friction. Friction. What's friction? Frictional force is a contact force exerted by a surface on an object in which it is contact with. It acts parallel to the surface of contact, opposite to where the object is moving. Also, it is also always perpendicular siya sa normal force, no? Always perpendicular to the normal force. Always yan, always. Kaya tayo nagkaka-friction kasi yung mga stuff natin, hindi siya perfectly smooth, no? Hindi siya perfectly smooth. They're rough up to some extent. Kaya nagkakaroon ng friction. So, kinetic friction acts when an object slides over a surface. No? Pag gumagalaw yung object, kinetic. Kaya nga siya kinetic eh. Where mu k is the kinetic friction coefficient, given yan parati, and n is the magnitude of the normal force acting on the object. And static friction refers to a force parallel to the two surfaces that can arise when they are not sliding to keep the object in place. Us is the coefficient of static friction and n is the magnitude of the normal force acting on the object. Tapos tatandaan natin, as long as the magnitude of the static friction caused by an exerted force or yung applied force does not exceed the maximum static friction provided by the surface, hindi gagalaw yung object. No? Or in short, applied force as long as less than or equal to Fs max, hindi siya gagalaw, no? Thus, once the value of friction exceeds that of the minimum, gagalaw na yung object. And yung magnitude ng force, always yan, hindi na siya magbabago, is mu kn, no? Mu kn. So, just a short illustration through a graph. Yan. So, at first, yung applied force, back sits at rest, static friction, 0. Ngayon, weak force is applied. Take note that the applied force is less than that of the maximum. Paakyat yan hanggang dito. Nakarating na, no? Equal lang. Tapos, habang nilaksan, yan, nagagalaw na. No? Nagagalaw na. And bababa yung friction. Okay? There we go. And constant yung friction after. Ito yung examples of coefficients of kinetic friction. Tapos ito, I'll demonstrate. Sige, I'll demonstrate. Okay? Okay, sige, game, ha? Take a note of the given. I'll give you a minute to take a note of the given. Okay, Kim, let's discuss. Oh, look at the board. Okay. Gima? Oh. Ito na. Dito tayo mag-drawing ng free body diagram. Okay? Oh, look. Teka, meron pa bang tanong? Okay, wala na. Free body diagram. Let's draw the free body diagram. So, I'm just going to draw yung mga forces na meron sa box. Diba? Normal force, weight, applied force, friction, no? Ayan, let's draw yung Let's draw yung free body diagram, okay? I'll discuss more of this later, pero the key is to look at each component, no? Hindi natin alam kung gagalaw. So, determine the force of friction acting on the box if a horizontal applied force is exerted on it of magnitude. Okay. So, let's get the maximum frictional force na kayang isupport ng surface. Equals to mu S times N, no? Saan equal yung N? Hindi gumagalaw hindi naman tumatalon yung object, di ba? Hindi tumatalon yung object, hindi siya gumagalaw at all sa y-axis. So, it's safe to say na sum of Fy equals to 0. Fn minus W equals 0. Normal force equals to weight equals mg. Yan. mg mu s. So, that is equal to 10 times 9.8 times mu s, which is 4.4. So, as long as yung applied force natin does not move, as long as yung applied force natin does not exceed, everything will get this, 39.2 newtons. Yan ang maximum force na kaya i-provide ng surface. Okay, let's go. Let's look at tandaan nyo to 39.2 newtons. So, as long as it doesn't exceed, okay pa tayo. Ngayon, find the friction, magnitude of friction. Let's look at the x-axis naman. Hindi pa rin siya gumagalaw, di ba? As long as applied force is not greater than this. So, Fx equals 0 equals to Fa minus friction, no? Friction. So, F equals Fa. As long as less than 39.2 yung applied force. Okay? So, at kapag 0 yung applied force, 0 yung friction. Kapag 10 newtons, yung applied force, 10 newtons yung friction. Kapag 20 newtons yung applied force, 20 newtons yung friction. And kapag 38 newtons, hindi pa rin siya mas malakas dito. 38 newtons na yung applied ay yung friction natin. Ngayon, 40 newtons. Diba? More than 39.2 newtons na yon. So, what do? We use kinetic friction. Kinetic friction na ngayon. Diba? So, Fk equals to, hindi na siya nagbabago, no? Mu K N. Mu K mg equals 0.3 times 10 times 9.8, we will get an answer of 29.4 newtons. Okay, I'll give you a minute to process. And if may tanong kayo, please ask right away. Okay? If wala naman, sige. I'll just give you a minute to process. Okay, game. Problem solving. Game. Problem solving. So, paano mag-solve ng problems sa dynamics? No? Paano nga ba mag-solve ng problems sa dynamics? So, unang-una, draw your free body diagram as you have seen. Next is resolve forces along the x and y. And lastly, use Newton's first and second law to solve the required quantities. Yung mga quantities na kailangan niya. So, sige, let's try this. Just listen to me. For now, ako na lang muna mag-discuss. Then, meron din kayo sasagutan in a while. Teka lang, let me see kung nandito pa. Yes, nandito pa. Wait Okay, nandito pa. Okay, sige. Ito yung mga basics, no? The basics. Okay, that's the given. Same box, no? Same box. Ang sabi, weight, normal force. Yun lang naman. So, let's draw the free body diagram. N, weight. Okay? Sum of forces along y equals 0. Kasi hindi naman sinabing wala namang nangyayari. Resting, ngayon nakasuot resting. Equals n minus w. Okay, ba't nga pala minus, no? Kasi pababa to, guys. Parang resolving of components lang, vector components, di ba? Kung ano yung pataas siya. Kung ano yung pababa siya. Okay. So, n equals w equals mg. That is equal to 98 newtons. And pareho rin ng normal force, di ba? Next. Ngayon, if we look at the problem, it pushes down ng 40 newtons. Yung friend mo, pushes down ng 40 newtons. Okay, ito yung gagawin ko sa free body diagram, plus FA. Yan lang. Ano yung tanong? Find the normal force exerted on the box by the table. Diba? Find the normal force exerted by the box on the table. So, ganun pa rin. Let's examine the y component. Hindi naman siya gumagalaw. Sa x, we don't need to examine anything kasi wala nang forces along x. So, n minus w plus fa equals 0. N equals w plus fa equals mg plus 40. That is equal to, sabi natin kanina, yung mg, that is 10 times 9.8 plus 40. So, we get 138 newtons. Yan yung normal force. Next. Pulls upward with a force of 40 newtons. What now is the normal force exerted on the box by the table? So, sige, dito na tayo dito tayo may gagawin, okay? Ngayon naman daw, pull upward. Balitan natin to. Okay, ito yung tanong ko. Gagalaw ba siya? Along the y-axis? Kasi diba, tinry niya i-lift up. Compare natin yung applied force sa weight muna. Kasi if gagalaw yung object, ang ilalagay natin dito is MA. If hindi, 0 lang. Okay? Kasi in-equilibrium pa rin yun. So, let's see. Yung applied force is 40. Ano nga ulit yung weight? mg, di ba? That is equal to 98 newtons. Mas maliit yung applied force kaysa sa weight. So, di pa rin siya gagalaw. No? So, let's do the necessary calculation. Ang tanong pa rin sa atin is, what is the normal force exerted on the box by the table? Same thing. Ngayon, babaguhin natin yung free body diagram natin. Same pa rin. N plus FA. Ito, weight. Di pa rin siya gagalaw, di ba? Sabi nga natin. Equals N plus FA minus W. Solve for n. N equals W minus FA. mg minus 40. mg is 98, di ba? So, 58 newtons. Next, o yan. Upward on the box with a force of 100 newtons. 100 newtons na raw, guys. 100 newtons na raw yung force na yun na paakyat. O, paano yon? Same thing. Compare applied force to the weight. 100 newtons, 98 newtons, di ba? Yan, mas malaki na to. So, for sure, gagalaw na yung object pataas. MA na. MA. MAY actually. Okay lang yun. MA. Ganun pa rin yung free body diagram. N plus FA minus W. Kaya lang, take note na actually, wala nang normal force, guys. Bakit wala nang normal force? Kasi mawawala na siya sa table, no? Mawawala na siya sa table. Malilift up. Tandaan nyo, ang normal force, kailangan in contact parati siya with the surface. So, if wala na yung object sa surface, edi wala nang normal force acting upon it. So, yun. Solving, AY equals to FA minus weight over M. 100 minus 98 over 10 kg. That is equal to 2 over 10.2. 0.2 meters per second squared. That's the acceleration of the box upward. Okay, before I continue, may tanong ba? I'll give a minute. Okay, wala. So, game, try this out. Sige nga. 5 minutes. So guys, I just take a CR break, huh? Sige, 2 minutes left. Sige, I'll give a little bit more time. 2 minutes. Clue. Kapag pababa yung acceleration, guys, yung acceleration ay negative din, no? Sige, 2 minutes extension. Okay, I'll discuss. Okay, game. May nag-message pa sa akin. Wala. Okay, game. Let's look at the board. Let's go off a body diagram. Kaya guys, ang tawag dyan, apparent weight loss, okay? Kaya kapag sumakay kayo sa elevator, di ba? Pag bumulis na sobra, minsan sabi sa rin, ba't parang gaan ko, di ba? So sige, let's see. Acting forces on the woman, force, Normal force, tsaka weight, di ba? Normal force ng scale, tsaka yung weight, di ba? Yun lang. O, game. First question. What is the weight of the woman? O, malamang, the weight of the woman is mg muna. Di ba? Mg. Take note, iba yung weighing scale. Iba yung nababasa ng weighing scale sa totoo mong weight, ha? O. Okay, game. mg, so that is 65 times 9.8. You will get around 640 newtons, no? Yun yung weight mo. Next. What is being read by the scale? What is being read by the scale, no? Let's get the normal force. Kasi yung mababasahin yung scale, eh. Kung ano may normal force, yun yung weight na nababasa ng scale, no? Quote and quote, weight. Sige. So, summation of forces, may acceleration daw, m times ay equals to normal force minus weight, di ba? Substituting Fn equals may plus weight. Ito ay negative, no? 0.20 g. 0.20 g daw yung acceleration. Downward, 0.20 g times m. Negative ba? Kasi pababa siya. Okay? Plus mg. So, 0.80 g. Ayan. Times m pala. 0.80 mg. No? 0.80 mg. Yan. So, yun yung nababasa ng scale na weight. So, get the mass. So, di ba, weight, quote and quote, equals mg. M, yung nababasa, equals weight over g. So, that is 0.80 m, which is 52 kg. Yan, 52 kg. Yung nababasa ng scale. Next na tanong. What does the scale read when the elevator descends at a constant speed of 2 meters per second? Ito, I won't compute na. Kasi, pag nagde-descend at constant speed yung elevator, ibig sabihin, no acceleration, no? So, net force is 0. Fn, normal force, equals to weight. So, kung ano yung mass mo, yun na yung nababasa ng scale, 65 kilograms. Ayan, I hope I made myself clear. Sige. Ayan if you want to take notes sa solution ko, please do so. Kasi we'll be doing this a lot of times, okay? Teka guys, game. Let's look at this one. Let's examine this one. A friend asks to examine the 10 kilogram box. The same box pa rin kanina. Ngayon, meron ng ganito. Calculate the acceleration of the box and the magnitude of the upward force exerted by the table in the box. Ito, perfect example kung bakit normal force is not equal to weight all the time. No? This is the normal force. Yun na yung tinatawag niya, normal force. So, let's draw the free body diagram. Yun yung mga forces. Ito lang, no? Ito yung free body diagram natin. Normal force, weight, applied force. Okay? Let's go to the board and answer the problem. Ngayon, may nagpo-pull na, 30 degrees. Weight, normal force, no? Drawing the free body diagram, ito lang siya. Normal force, pull, FA, tas weight, di ba? Ngayon, let's separate the forces into components. Kailangan natin is normal force, di ba? Pero unang-una, let's calculate Kung yung force ba yun, yung force ba na in-exert ng tao, can lift the object up. Paano yun? Diba, ang normal force is 40 newtons. So get the y component. 40 sine 30. That is 20 newtons. Compared to the weight ng box, di ba, mg equals 98. Mas malaki to. So, hindi aakyat yung box kahit anong mangyari, okay? So, we are safe to assume na sum of forces along y is in equilibrium kasi nga hindi gumagalaw sa taas, 0 equals to n normal force plus FAY, which is 20, di ba? Minus mg, wait, 98, equals 0. So, n equals 78 newtons. Ang nasagot ko pala ay yung letter D. No? Yan pala agad na sagot ko. Let's go to the x-axis. No? Nag-accelerate daw siya. Alam naman natin hindi nag-accelerate sa y-axis, so sa x lang natin lalagyan. MAX, no? MAX. Pero dahil wala naman acceleration sa y, so yun yung acceleration system. Equals FA cosine 30. So, 40 times square root of 3 over 2, 20 square root of 3, no? 20 square root of 3. Get the acceleration, 20 square root of 3 over 10 to square root of 3, or ayaw nating radicals, so 3.46 meters per second squared. Yan. Yan yung sagot ko. Tama. See? Okay. Ilang minutes na lang ba tayo? 30 minutes. Okay, next. Ito naman, tension. No? Let's go with the concept of tension. So, ayan. Connected by a lightweight cord. Ito raw yung cord na yun. The boxes have masses 12 and 10 kilograms. A horizontal force of 40 newtons is applied to the 10 kilograms box. Find the acceleration of each box and the tension in the cord. Yung tension daw dito. Okay. Ito, let's create the free body diagram. Ito lang siya. For each. Yan. Okay. The system is connected by a flexible and The system is connected by a flexible and massless cord. So, kapag flexible and massless yung cord, pag flexible and massless yung cord, pareho na yung acceleration ng system, okay? And pareho lang din, lalo na yung tension, kasi they're the same string. So, I'm going to draw the free body diagram for both of these. So, look at the board. Ang tinatanong sa atin is, what is the magnitude of the tension and also the acceleration of each box? Okay, game. Box B. Box B. Ito yung sa box B. N. Weight. Applied force. No, tension lang. Tension. Tension, no? Ito yung sa B. Yan dito, box B. A. Sa A, yan, 4 yung sa kanya. A. Tapos yung T niya, pag ganito. Di ba sabi ko, palabas yung tension from the cord na na-connect sa box. Okay. So, let's examine each box, A and B, para malaman natin what to do. Okay? Let's examine B. Obviously, kailangan na natin ay yung tension and acceleration, di ba? So, nagbigay ba siya ng mass? Meron. So, sige, let's look at everything. No? Let's look at everything. Sa B, sum of forces sa B, Y, equals 0 kasi di naman tumatalon, di naman gumagalaw along the y-axis, no? So, equals to 0 equals n minus w. So, n equals mg, just in case we need. Next, x-axis. May acceleration daw dyan. mb a x. Pero a lang kasi wala namang iba. Equals t. Next, ay. fay equals 0 equals n minus w. Lagay ko lang dito just in case we need. Sum of ax. Yan, may gumagalaw dyan. a equals to right minus left. Applied force minus tension. Substitute here. MAA equals FA minus MBB. MBA, no? So, solving, A equals FA over MA plus MB. Diba? Ang force is 40 over 12 plus 10, which is 22. Diba? And our acceleration is already there. 1.8. No? 1.8. Ngayon, we need the tension, di ba? We need the tension. So, substitute ko lang dito. T equals to, ano ba yung given natin? Mass of B equals 12, no? 12 times 1.8 equals 21.8 newtons. So, let's see our answer kung tama. Yes, it's correct. No? Ayan. Let's see how much time is left. Sige, marami pa pala to. Pulleys, inclines. Okay. More problems in friction. Ito. We go back to our box ulit kanina. Diba, na-determine na natin kanina na hindi gagalaw yung object. Kasi pareho lang 40 newtons, diba? Hindi siya gagalaw pataas, no? Okay, so that makes our process faster. And sinabi naman na gagalaw yung box. Kasi implied na gagalaw yung box kasi yung binigay is mu k, no? Don't worry kapag walang binigay na static friction. Okay? Sige, game. Let's discuss. Normal force, weight, friction, and, ito pala yun, applied force. 30. Drawing the free body diagram. Ito na, dumadami na yung laman. Weight, normal force, friction, applied force, friction, or simply F, no? Okay, let's resolve the X and Y components muna. So, ano hinahanap sa atin? Calculate the acceleration of the box. Sige, first things first, malilift niya ba yung box? Yung pull ng force, yung y component ng applied force is equal to 40 sine 30, which is equal to 20. Diba? 20 is less than mg, which is equal to 98. So, 20 is less than mg, which is equal to 98. So, hindi malilift yung box. No? So, sa x lang siya magkaka-component. Summation of Fy equals to 0 equals to n plus Fa sine 30, which is 20, minus weight, which is 98. N equals 78 newtons. Ngayon, what's next? X naman. MA equals to applied force. So, cosine 30, 40 cosine 30, that is, sige, sulat ko na lang, 40 cosine 30. Minus frictional force, which is mu Kn. Kasi gumagalaw daw with the kinetic friction. Mu K equals 30, so, yan, 40 cosine 30 minus 0.30 times 78. A equals ito over M, which is 10. So, solving for that, 40 cosine 30 minus 0.30 times 78 over 10. 1.12 meters per second square. Ayan. So, that's it. Let's see if tama yung sagot ko natin. Tama. Okay, before I move on, may tanong naman wala. Kasi if none, I will move on. Sige, I'll give you 2 minutes to absorb. Okay, sige, let's continue. Sige. Pulleys. Okay, game. Paano to? Teka lang ha. Last 2 na lang pala to. Okay. Pulleys. 2 boxes are connected by a cord running over a pulley. The coefficient of kinetic friction between box A and the table is 0.20. Find the acceleration of the system. Okay. We ignore the mass of the cord and the friction of the pulley. No? So, kumbaga, katulad lang sa kanina, pareho lang yung tension nito kasi same cord lang naman sila. Also, ano pa nga ba yung isa? Pareho lang sila na acceleration. Okay? Pareho lang sila na acceleration. Okay? Kasi hindi naman nag-stretch yung cord. Okay? So now, let's go. Let's do this. Mahaba-haba to. Anong tanong? Find the acceleration of the system, di ba? Yes. Okay. Let's go. Pulley. Five kg, 2 kg. Okay. Free body diagram na A. Okay, ito pa yung isang technique. Kapag maraming system or maraming object na tinitignan, gawan nyo na free body diagram lahat. Kasi it would prove useful. may kinetic friction. Okay? So, sa A, ito yung free body diagram. Oh. Tension, friction, normal force. Wait. Sa B, ito lang yung, ito sa A. Sa B, ito. Tension and weight. No? Yung acceleration niya, hindi free fall. Hindi siya free fall. Okay, bakit? Hindi naman, kasi merong friction, no? Merong friction. And may force kasi due to the 5 kilograms, no? So, hindi siya free fall. Hindi 9.8 meters per second squared yung acceleration. Okay? Next. Oh, paano to? Look at A, look at B. Oh, A. Paano si A? Sum of F, A, let's examine both systems, no? Sum of FAY equals 0 kasi hindi naman siya tumatalon or hindi naman siya gumagalaw pa ganon. So, N minus W. N equals W equals MAG. Okay. Sum of FAX. MA. No, MA. Pareho lang. MAA. No, MAA. Equals tension to the right minus friction. Friction. Ayan, sige. Mamaya na yung iba. Ngayon, let's look at B. Y lang yung meron kasi walang X, no? Ayan, meron yan. Negative. MBA. Bakit? Kasi pababa yung acceleration. Negative yon, okay? Negative. Equals to tension minus weight. Acceleration na naman hanap natin. So, if we subtract both, we'll get our answer. So, subtracting, solving systems, no? Itong dalawa. Oh. MAA plus MBA equals W minus F. A equals, W is MBG. Palitan ko na, no? Para hindi tayo malito. Equals to MBG minus F over MA plus MB. MBG. Ano tong F? A, di ba? Friction ng A. Mu K times normal force ng A. So, mu K MAG over MA plus MB. Calculating this long answer, we'll get this. And we get this. Tama ako. 1.4 meters per second squared. Sa problem set natin on dynamics, you'll encounter very many. Dami pa. Sobrang dami pang bukod dito. I'm going to give 2 minutes to absorb. Or 3 minutes muna. Tell me if you have any questions. Sige, take a break for 3 minutes muna. Yeah, take time to read all of that muna or understand. Let's start at 5:35 ulit. Sige, last minute. Guys, nakukuha ba yung ginagawa natin? Kasi pag hindi, pakisabi lang, no? Kasi sayang naman yung mga sinulat ko dito. Wag di nyo gets. Gets ba? Nakukuha ba? Nico, ayun, oh. At least, sige, ulitin natin. Okay, ulitin natin. Um, yung previous parts, nakukuha ba? Hindi. Dali, honestly. How about, ano yung, teka, what do you, ano yung, okay, itong example na to, sige, ulitin natin. No problem, no problem. Sige, game ha. Game. Let's go back. Oh, two boxes are connected by a cord running over a pulley. The connection of the coefficient of kinetic friction between box A and the table is 0.20. Find the acceleration of the system. Okay. Oh, game. Ito yung system natin, di ba? Sabi ko, as long as boxes are connected by cords, na same cord, non-stretchable, massless, pareho lang yung tension nila. Also, pareho lang yung magnitude ng acceleration nila. Okay? Always remember that. Kasi pag hindi pareho yung magnitude ng acceleration, gagamit pa tayo ng ibang variables dito, which would be really hard for us. Pero the laws of physics say na equal sila ng magnitude of acceleration. Okay? Sige. Now, let's start. Let's examine each box, no? Let's make the free body diagrams first. So for A, ito lang siya. 'Di ba? Meron siyang normal force pataas, meron siyang weight bababa, meron siyang wala siyang applied force, kundi tension dito. 'Di ba? Palabas parating yung direction ng tension, palabas from the object. So that's tension. And lastly, meron din siyang kinetic friction. Frictional force. Di ba sabi kanina sa problem? O, yan. F. Okay? Next. Yung B naman. Tension tsaka weight. Di ba? Tension tsaka weight. Di ba? Yun na yung meron. So now, let's examine the X and Y components of the forces of box A and box B. Box A. Sa Y component, hindi siya gumagalaw at all, di ba? Kasi hindi siya tumatalon or anything. So, zero yung net force. In equilibrium, dito. Equals to normal force minus the weight. Normal force is then equal to the weight is equal to MAG. Important yung normal force kasi kailangan natin ng frictional force. Okay? Now, kailangan natin ng frictional force for box A. Now, let's resolve yung free body diagrams natin. For A, the X component of A, mass of A times the acceleration equals tension minus friction. Diba? Tension minus friction. Yan na siya. Next. For B naman, it is equal to the negative of the mass of B times A. Bakit? Or rather, negative A siya. Bakit? Kasi, negative A, no? Negative A. So, lagay ko lang nandito. Bakit siya negative A? Kasi pababa yung object. Pababa yung object. So, pababa yung acceleration. So, dapat negative yung value niya. So, it's equal to tension minus weight, no? Tension minus weight. Okay? Yan. Weight is mBg. Okay? Next. Ngayon, let's solve for the acceleration. Subtract the equations, you'll get this. MAA plus MBA equals MBg minus friction. Yan na. Solve for A, we'll get this. Friction is mu k times normal force of A, which is MAG. You will get, if you substitute all the values in the end, 1.4 meters per second squared. There, is that better? Okay na ba? Okay, sige. Last one. Last for today. Mas meron na homework for enrichment para sa inyo. You can answer it if you want. Okay. Ito. Paano naman kung incline? Okay? Paano naman kung incline? Incline is inclined plane. Anything sloped, no? So, let's see. Walang mass, no? Walang mass na binigay. Kakapagtaka, no? Pero okay lang yan. Theta. Yun yung pinakaunang-unang alahanin. What is her acceleration? What is the acceleration, no? Oh, this is the free body diagram, okay? Kaya lang guys, 'di ba, instead, 'di ba dati ang x-axis, y-axis natin parating ganyan, no? Dito hindi. Kapag incline, so sundan niyo yung direction ng normal force and ng motion, okay? Sundan niyo yung let the x-axis be the motion, let the y-axis be the normal force. So yan, this is a very good representation of what should be done. Tapos, yan, no? Fixing this, may ganito siya, no? Ikutin ko siya ng onte, may ganito siya. And, wait. Waitin ko. And, force. Joke lang. Let's use the board na lang. Let's